Okay, we're back and we're going to be looking at the output component, the buzzer. In this instance, we've replaced the LED with the buzzer on track 40. It's straddling both the left-hand side and the right-hand side of track 40. And so what I'm going to first of all do is connect a low from the buzzer. So that is going from track 40, I should say, row 40. It's row 40, sorry, to the low. And then I'm going to make another mechanical switch going from 40 and then just going from the high. Should probably use a red for that, I think. Used a blue last time. And then hopefully... It's worth noting with this buzzer as well, the buzzer has a long leg and that has to go towards the high side of the circuit, and a short leg that goes towards the low side of the circuit. So first of all, what I've got is I've got a buzzer that works, which is a bit of fun. And now what I'm going to try and do is use something else to activate that. So the buzzer is quite a high consuming product, as in it consumes quite a lot of electricity. And if I put a resistor, for example, an LDR, into position, well, you might be able to hear it. No, I can't hear it. But sometimes you can just hear the faintest buzzes when you plug in the LDR. But fundamentally, not enough electricity is coming over the LDR and through the buzzer to activate the sound, which is a bit annoying because, of course, I want to control the buzzer with my LDR. So what do? Well, what you need to do is use something called a transistor. So let's take out that LDR and let's have a look at our transistor. This is our transistor. I like to have it so that the curved side, this side here, is closest to us. Now, we have three legs. Now, the leg on the left is called the collector. The leg on the right is called the emitter. So the collector goes towards the high side of the circuit and the emitter goes towards the low side of the circuit. And then in the middle, you've got the base, I think it is. But that fundamentally is the pin that when you send it high, so from 0 volts to above 0.6 volts, it begins to turn on. When I say it begins to turn on, it begins to allow electricity to flow over it. Now, the great thing about a transistor, it only takes a very little amount of electricity to allow a lot of electricity to flow over it. And so you can get very low powered devices, like, for example, your LDR, enabling much more high powered devices like the buzzer. So enough of talking, let's have a look. So with the curved side, I'm going to turn that clockwise, so the curved side is facing to the left. I'm then going to put the top pin, which is the collector, into row 40. Done. All right, that's good. It's worth noting that with a transistor, that the load has to go before the transistor. So it's not that you don't get the transistor and then you get the buzzer. You have the high, you have the load, and then you have the transistor, which is a little bit confusing sometimes. So we have the high in the wrong place. Sorry, the low in the wrong place on this. We're going to bring that down to 42, where the emitter is. And then what we're going to do is we are going to put the high on row 40. So we've got the high going to the buzzer on row 40, the buzzer jumping from row 40 to 40, and then we've got the collector on row 40, we've got the emitter on row 42, and then the emitter goes low. But this is not going to work until that middle leg goes high. Now, I'm just going to use a resistor because I don't want to blow my transistor. What I'm hoping, quite a big resistor. I thought that was a 1K, but can you see the orange on it? That is actually the 10K. Can you hear the tiniest of tiny squeaks on that? Instead, of the 10K, I am going to use my 1K. I think the 10K was just too big. There we go. So I'm touching the middle leg. That transistor is nice and happy because not too much energy is going through the base, but it's also turning on. So I'm going to call it there and let you do that before I go on to the next part of, and next and final, I will say, the next and final part of our little practical theory lesson.